let's discuss the solution to this lab. I'm going to walk through all of the steps, even though I know that you must have already started this lab and basically have this file open, the ACME Corporate Forensics PCAP-NG file. But just for the sake of clarity and completeness, I'll walk through the entire lab once again. So the first step is to run the main script and start the ACME Corporate Breach lab. So I'm going to go to desktop, labs folder, and then sudo /main script, Kelly, and then we need to start the Wireshark ACME Corporate Breach Lab as mentioned here. Okay, so I'm going to go with choice 6, and the lab is ready to use. Okay, great. So now the next step is to basically open this file, Wireshark ACME Corporate Forensics.pcap-ng. Okay, so let me do that. So let's go here. Let's go to sniffing and spoofing, Wireshark, file, open, and I'll just browse once again just for the sake of clarity. So let's say you can go to Home Kelly, Desktop, Labs, Wireshark ACME Corporate, and then ACME Corporate Forensics.pcap-ng. Okay. So here is the file. So let's start with the first part, baseline traffic familiarization. Identify any email traffic sent internally, who sent it and what was the content. So as we already know, email traffic is always sent using SMTP protocol. And here's where we are going to start applying the concepts that we have learned. We're going to leverage display filters and we're going to say just display SMTP traffic. Okay, and we found 2 packets. However, it's also easy to sort of even browse through this traffic and sort of identify it from here and here. But just for the sake of ease, let's filter it on SMTP traffic. Okay, so we see 2 different SMTP sessions or packets. Let's check the first one. So this was sent from 10.0.0.102, which is this one, 10.0.0.102, which is the mail server. Excellent. But let's check the contents actually. Okay, so I'm going to right click it and follow the TCP stream. Okay, this is coming from admin@acmecorp.local. So this is a local domain, Acme Corp's own domain. So it is coming from the admin. That's fine. It's going to Brian. Okay, that's nice. And what's the subject? Maintenance reminder. Hi Brian, reminder for system maintenance tomorrow at 7 p.m. I think that looks perfectly fine. Okay, so we are seeing one email from admin sent to Brian, sent to the same SMTP server, because obviously admins and Brian's and everyone else's inbox will be on that SMTP server. Every employee accesses his inbox on the SMTP server. Okay, so far so good. Now let me just go back to the SMTP one. So this was the first one that we observed. This is the second one. Interesting. This seems to be going to John, but let's just follow the TCP stream and let's see the actual content. Interesting. So this is not coming from acmecorp.local. This is coming from corp-updates.net, completely different domain. And it is going to John Doe at acme-corp.local. Interesting. This already looks suspicious because this is coming from an outside source. Subject, urgent HR policy update. Dear John, please download the new HR policy. And then they have inserted a link. Regards IT department. Interesting. So already we have sort of identified the red flag. So clearly this is a phishing email, which also sort of like answers the next question, what attack vector was used? So the attack vector that was used was phishing email, and who was sent it to? So the employee that was targeted was John, which is here, and John's IP address is 10.0.0.10. Interesting. So Mr. John got compromised, this gray system. So we've already checked the normal email as well as the malicious email. We have identified the attack vector, phishing email, and employee John. And then let's move on. How did the malware installation take place exactly? And what was the source of the malware? So now we need to put our forensic hats on once again and investigate who did John talk to. Okay, so for this one, ip.adder equal to John's IP address 10.0.0.10. Okay, so this is going to give us all of the traffic which is either going to John or coming from John. Okay, that's nice. Okay, so this is going from John to Google's DNS server. You remember 8.8.8, or you can also see here 8.8.8 is Google's DNS server. Anyways, so John has sent a packet to Google's DNS server, and what is he trying to resolve? Let's check the packet, the query, and what is his query? This seems like a normal one. ACME Corp local. It seems to be a local DNS query for some reason. That's fine, and this is clearly the response. Query response. That's fine. What's this one? Okay, this seems to be a bit suspicious, so let's investigate that. Oh, he's just visiting NewYorkTimes.com. That's fine as well. I just need to go back. Let me just copy this one so that we don't have to type it again and again. Okay, what else has John been up to? Again, he's going to New York Times. He seems to be a big fan of NewYorkTimes.com. That's fine. Okay, what else? What else? I don't see anything suspicious here. Again, New York Times. He's spending a lot of time on NewYorkTimes.com, reading a lot of news articles. Okay, this is get home. Again, internal IP address, internal IP address, internal IP. Oh, what's this? This seems to be an external IP address. That seems really suspicious. So let's explore that. There you go. Here is when he clicked on that link, if you recall. This is where the malicious software was basically downloaded. So just to answer this question, how did the malware installation take place exactly? It took place when John clicked on that link in his phishing email and he landed on this domain 198.51.100.5. And then this domain basically had the malware which got installed on John's system. But just to be sure, let's check. Did John actually resolve this IP address? I just want to see that. So we can put John's IP address and DNS. Okay. Did he resolve that IP address? Malicious downloads. Sorry, the screen is a little smaller. So malicious downloads, let's just quickly check the packet. So what was the query? Malicious download, and in the answer, Google responded, this is the IP address, exactly the same IP address. There you go. So this is the malicious IP address. And what was the domain name? The domain name seems to be malicious.download. Okay, so we have answered this part as well. Next one, which internal server or services did the malware try to access? So once again, this would be related to John. So let's continue checking the traffic of John. However, now we know we have two servers, right? We have this one, web server, and we have the database server. So let's check if John has been sending any traffic to the web server. Okay. Okay, so now not just all the packet going or coming to John, we need to find, did he initiate anything? There's still a lot of traffic, so let's use another filter. And is it going to, for example, the web server? Let's check that one first. And ip.destination equal to, and what's the IP address of the web server? 10.0.0.100. Okay, 10.0.0.100. There seems to be a lot of traffic going to the local web server, but it all seems very safe. What about the other server, the database server 10.0.0.101? So investigate that. Aha, that seems interesting. So once again, follow TCP stream is our friend. Let's check what is going on. Select user password from employees where role is equal to admin. So John has been running SQL queries and sending to the database server, the SQL database server, and in response, he got this answer. That seems really serious. And here also, if you check, So for example, if you check the port, destination port 3306, this is the well-known port for SQL database servers. Interesting. So that was his first query. And what was his next query? Filter. And what was it? Since I don't want to keep on typing this IP addresses once again, so we can use another option, because if I do a follow TCP stream here and then come back, so it's going to just show that particular sequence. So one nice thing, if you have written this query and you don't want to type it again, obviously you can copy it. That's one option. But in Wireshark, you can do, so for example, if I go here, you can click plus, and then you need to provide a description. So for example, let me just say DB queries. There you go. So now I don't need to remember it. I can just go here and click this one, and it's going to land me on the same page. Okay. So the first one was follow TCP stream. Just to repeat it again, this one was an SQL query in which the malware queried the employees table to get usernames and passwords. Okay. So I'll just go back to DB query. And then let's see the second one. What happened here? So basically, as you can see, it called it 3 times. So we have to investigate all 3. Follow TCP stream, select social security number and salary from payroll. Interesting. So the malware also tried to fetch the social security numbers and salaries from the payroll table. Okay, and what was the last one? Sorry, let me just scroll here to DB queries. You can do this easily once you have it in full screen, but I have this lab opened on the right side. So let's see the third one. Once again, going from John's system to DB server. And what did it run this time? Select email and phone numbers from contacts. So basically, the malware exfiltrated 3 different types of information or data. Number 1, username, passwords. Number 2, social security number and salaries. And number 3, emails and contact information. So that sounds pretty bad. Let's move to the next part, data exfiltration. So now the malware clearly has all of this information. So basically, the malware from John's system queried the database server and has all of that information now locally. And now clearly it's going to try to send it to some remote malicious host here. Okay. Now let's investigate that one. So once again, we'll have to do ip.source equal to John's IP address. And let's see if he has done any DNS queries or TCP sessions more. Okay, this was the malicious one. I don't see much here, but let's just see what else has John's system been up to. Well, I see a TCP connection to an unknown IP address. 203.0.113.77. But there should have been DNS traffic for that. Maybe the malware had the IP address hard-coded. That's one explanation, which would explain that why we can't find the DNS resolution for this one. But let's follow the TCP stream and let's see what is actually inside this session. There you go. This session contains all of this secret information that malware had extracted from the database. And it's perfectly fine to sometimes sort of lose your way, rethink your strategy, try different filters. This is a realistic investigation. Okay, and now I'll also explain the reasons why we didn't see the DNS packet for the DNS resolution for this IP address. So this IP address could be hard-coded. That's one thing. And secondly, it's probably using Netcat to directly sort of like create a session between the local system, John's system, and the remote malicious command and control station. And by the way, this IP address is different from the one that was involved in malware installation? So to answer this question, no, these two are different. For the malware installation, we had the different one, okay? So for example, let's go here. So for the malware one, it was a different IP, this one, malicious IP. And let me just change IP address. I also want to see the responses. Okay, and where is the Google's response for this one? Okay, so this was the IP address of the malicious host. Okay, you can also see it this way. This was the IP address of the server where the malicious payload was installed from, the domain. But now it's talking to an entirely different command and control station, and as we already saw, that it's sending the exfiltrated traffic. Okay, that concludes our lab. And it's perfectly fine to sort of rethink your strategy, try different filters. Sometimes you won't find specific information, but that's part of forensic investigation. I hope you've learned some valuable lessons in this lab. Thank you.